There we go. We're live now with the Zach Jackson. Zach, it's very nice to meet you, sir. Always nice to meet a fellow Zach.
Yeah, this is what I think like the third or fourth one with the same spelling that I've run into in the past few
Oh,
years.
I hate Zach with just a C, like ZAC, and that's it.
Oh yeah.
Those
Or
are the worst.
actually, yeah, I know what you mean.
Yeah. So can I ask you this maybe? What is this is going to sound weird. What is on your birth certificate? Is it Zach or is it Zachary?
Zachary.
How do you spell that?
Still Zackary, not
Oh, okay.
CH.
So
Yeah.
I am Zachary on my birth certificate, but spelling
Okay.
Zach Zach makes no sense to me. I refuse to do
Yeah,
it.
Zach.
I know. I refuse to do that. I see other people just leaving around with Zach on there, and I don't get it. Like I just had to make the change. So it's not anything official, but I do make a point of doing ZACK for that kind of stuff. Excuse
Yeah,
me.
no,
Anyways,
everybody always puts it. It seems like the default is everyone always says CH, like whenever they write it down. That
yeah,
seems to be what everyone assumes.
that's the standard. I feel like yeah, for sure. But I don't know. I feel like I see more and more ZACHs. I think it's the only sane way to do it. So I like if you're ZAC, I assume your name is Zachariah or something like that.
Mm.
Because I don't think they Zachariah. How does one spell Zachariah? I feel like it's two C's and like more
I
stuff.
thought I
I don't
thought
know.
I thought that's where CH came from, was the old like biblical spelling, because don't they spell it with a like with Zechariah with the CH?
We're finding out. Let's see. How does one spell Zachariah? Zachariah. Okay, Zachariah is actually spelled Zechariah. That's
Oh
the
my gosh,
Zechariah from the New Testament.
imagine if
Oh,
somebody's name was Zech, but like so it was
get
Zach,
him
but
out of
that's how it's
here.
spelled. Get
Just get out.
It's like, is there a Zeech here?
Oh, you're slaying me here, Zach. You're slaying me. All right. Excuse me. That is enough of our hyper nuanced, hyper niche Zach conversation. Let's get into bundling. So I'm going to throw up on screen here just Excalibur now kind of drive the conversation. So um from and welcome to folks in the chat. I like that people have to say Mr. DeRose now instead of Zach. But yeah, I'll check out LinkedIn. I'm not interested in any job offers if that's what you're trying to sell. And yeah, Yannick, welcome. Good morning. All right, let's get into bundling because I feel like this is a loaded term, bundling and building, all that kind of stuff. What do we mean by that, Zach? And I have like some idea in my head what that means. But I want to hear it from you, if that's fair.
Okay, so bundling is essentially, I still kind of refer to it as like a form of compilation. Like I think at the end of the day,
Mm,
they're all compilers of some kind, but
yeah.
bundling is kind of like a subset of the compilers. But essentially, what they would mean is how we refer to them anyway is like you take a whole bunch of little things and you pack it all together into slices of something that's like less granular or more prepared. Bundling, there's generally three like major responsibilities of a bundler. Um, it would be the hold on, let me actually get the note up. um, so there's three. Hold on, let me just pull this up. My team actually wrote a really good thing on this.
Awesome. Is it like, would you like to share that directly? Otherwise, I can like take notes as we go. But
Yeah, I can. Yeah. Okay, yeah. So I will share the screen here. So we have this thing called, we wrote this. this blog post like around the rationale of why we built Rspack,
Mhm.
and it's
Oh,
a
are you sharing it, Zach? I don't. Oh, there it is.
it's
Got it.
coming up now. There we go.
Cool.
So this is just if you just Google like the rationale behind Rspack, it will it'll come up. Um,
Gotcha.
but essentially, there's like three major aspects to bundling. So one of them is transformation. Yeah, here we are. So it's essentially you would have transformation, which is like converting things, or like, yeah, basically taking something from one language, putting it into another language. Um, then there's filtering, which is like essentially if you think of loaders. So I'm going to say, okay, I want to find, like in this example, let's say an SVG. So you would say, I want to grab an SVG, and so that's the filtration step. You want to test a certain type of file and find it.
Yeah.
JSX, SVG, CSS. So there's filtration. Then there's conversion or transformation. So taking it from one syntax into another, say SVG to JSX. And then finally, there's module type conversion. So this would mean
Okay.
changing it from maybe a CJS to ESM, or JS to CSS, or JS to JSON, or image format into maybe base64 or something like that. So that's kind of
Gotcha.
the general responsibility of a bundler. You want to filter certain things, you want to convert them, and then you want to change the module types that they are.
Okay. That makes sense.
So
That
that's essentially, yeah, that's kind of like when you think of a bundler, that's what you're looking for. Something that's going to find your assets, be able to convert them into other things, and then change the format that they're actually stored in as
I
well.
see. So
And then
like
obviously we would have something like splitting them into chunks and so on and so forth. But essentially a
okay.
bundler is, those three elements plus maybe like a chunk graph or optimizing.
Gotcha. That makes sense. Let me share my screen again, because this was one of the questions that immediately came up to me. We can kind of get rid of this because we talked about that. But one of the things that came up to me, like, would you consider Babel a bundler? Because as I
Mm.
understood it, and maybe my understanding is limited, but Babel was like, let's take this newer ES version of JavaScript and let's transpose this to something that any browser could use. In your mind, is that a bundler, or does this not qualify yet at that point?
I would say it doesn't qualify as a bundler. This would be the transform step. So this
Okay,
is the transformation. So this is say taking JSX and down leveling it in ES5, or taking an SVG and converting it into JSX.
I
So
see.
SWC and Babel, I wouldn't consider them bundlers because they don't pack things together. They just help you with transformation of one thing into a different variant of that thing.
Okay, so this is doing one of like the subset of things that bundlers do, but it is not itself bundling. Okay,
Yeah.
cool. Cool. So like if we compare that to Webpack, Webpack is doing, well, I don't know actually. You said there's like the transform pack or this transform set step. Is that something that Webpack is doing itself, or is it using a tool like Babel to do that?
Built into Webpack, it has its own transform. If you say take a ES6, it doesn't really transform per se, like in terms of it won't down level something. So if you put a const in your code, a const will end up in your build code. But it does in terms of transform, as in say, oh well, if I have ESM here and I want to build common JS, it will change, the imports into requires, and it'll convert the module typing for you, or base 64. But usually in order to make them more flexible, that's where the loaders kind of come in. There might be some
Mhm.
built-in loaders and things like that but for the most part, we like to use like the third-party ones to have more flexibility. But technically Webpack can work without anything, without
Mhm.
any plugins or whatever. But generally, uh, that's what we go for because we write like more exotic code these days with varying specifications, and to pack all of that into the bundler as a default is uh, short-sighted.
Yeah, yeah, that makes sense. So you had mentioned something that had come in that had just like I wanted to jump down to one of these questions I had for later on. But so you mentioned like down leveling import statements to like requires. So I felt like that kind of opened the door up to this whole question of modules and how like so modules. Um, do you see maybe one question is like do you see common JS as the down step from ES modules, or do you see them as
Downstep is
like
in
two?
like a good or like as a lesser good thing
Yeah, I
versus
guess
the east.
versus like two things that are siblings. I guess.
So I would say each one has its own use case. Um, for me, what I see ESM as is ESM is a really good input format, but it's not the best output format.
Yeah.
So bundlers are really good at parsing ESM, at tree shaking it, and so on. CommonJS is a little bit more difficult to parse and optimize as well because you can do something like a dynamic export. So I could just say like, module exports equals a variable like a
Right.
reduce loop that becomes the object at runtime. So there's nothing to
Right.
statically analyze. So it's a lot more difficult sometimes to uh, do that. But if we're talking like on the Node.js side, you can kind of hot reload CommonJS. You can't hot reload ESM. Once you import ESM, it's in memory, and the only way to get rid of it is to kill the process and start it again. If we're talking in the browser, I believe there's a similar constraint in the browser as well. So when it's like JavaScript, so how Webpack kind of does HMR, um, we use like this format called JSONP, which is like our own custom built module format kind of. It's
Cool.
essentially like each chunk creates like an object, and there's three exports on the object. One is the chunk's ID, the other one is like any dependent IDs, and the third one is a object of modules. And so we can delete a module out and put a new one in and unload it from memory. And we can always delete the script and add a new script to clear it. But with ESM, once it's imported, it's in memory, and all you can do is add more memory onto it. So we could still say remove the module from the graph and put a new one in, but the browser will just continue to leak memory up until a point where you need to refresh the page.
Hmm.
So ESM, again, really, really good input format, but as an output format, it's not super great. In my opinion, anyway, from
So
what we've
yeah,
kind of seen.
yeah. Let me. I'm sorry. I feel like I'm getting lost a little bit. But when you mention like output formats versus input formats, what we're talking about is like the input format would be like what developers would want to work with as they're developing. And then the output format would be then when
What
we
the
do the
runtime?
bundling, what do we
Yeah,
send out? What do we send out as our artifact?
yeah.
So I guess is that maybe a good way of understanding bundling is just like here's our input format, and then we want to get from that and we'll drive that to some sort of output format. Is that a
Essentially.
good okay.
Yeah, at a very high level, it's taking a bunch
Yeah,
of
yeah.
input files, converting them into an output with, phases like maybe optimization in there as well, so that we can reduce the number of network requests. So if
Right.
we look at,
Yeah.
say, something like Babel or maybe like Rollup back in the day, big challenge that kind of you would have with those builds. Well, there were two kind of problems with the or not Rollup, Babel or I'm thinking like a Babel, Gulp, or Grunt, like those type of things. They're too granular. So, a big problem with those is that, it was really good at piping stuff through. So you could say, all right, inside of my workflow, I could have a Babel task in Gulp, and that would convert everything.
Yeah.
And then if you wanted to make like one JS file out of it, I don't know, I think back in the day there was like something that could kind of do that, but essentially, it's a
Oh
lot
yeah.
harder to then pack it into a chunk.
Hmm.
Um, and then when bundling came along, it was a bit more omniscient. So you didn't really have like, oh, well, this thing handles images and then this thing handles the scripts, but you had something that understood the relationships between an image and a script, and you could import the image in the code or, whatever, and it would create like a link to that artifact and have a asset pipeline for it. Um, but essentially the bundling is, taking an input format, turning it into something a bit less granular, maybe more granular, maybe less granular, but in general, the ability to reduce the granularity of something, optimize it, and
Yeah,
then output it in some way that's, more ideal um, for the what I kind of refer to as the last mile
the
step,
last
which would be
mile.
like, okay,
Okay.
when it goes from server to the browser versus when it's
Yeah,
like an npm package. When it's an npm package, you could have different kind of bundling strategy. So
yeah,
often
yeah,
you'll see
yeah.
like you might use something like rollup for package bundling because it can do like preserve module tree or things like that, where
Yeah,
um, you don't really want chunks as much. You just want to take your code, keep the same shape more or less. You essentially want something that's a little bit more sophisticated than Babel.
yeah,
And that's kind of what rollup, that's how I always think of like rollup or ES build, is it's like a very fancy Babel.
yeah, yeah, yeah. So another interesting thing you bring up here, I feel like this right here, this is what we're looking at, which like I think a lot of things just distill down to this. It looks this looks like a function to me, right? Like here's some parameters, here's our return statement. But one of the interesting things that I feel like you're getting at is there's actually like this can actually apply to multiple similar but different things. And one of those is like building things out to like I'm building a website. This is what's normally at the top of my head. But there's other ways of doing that. And I think that's one of the things you brought up with rollup is that sometimes you don't want to build for the web. Sometimes you want to build for NPM. Like you want to build a package and put it out there. And so the desired output format here, I imagine, is much different because we're actually making this something that other people want to consume for their input, right?
Yeah,
So
you're emitting input formats for another thing. Essentially, whenever you're like, bundling is most effective at not the last mile or at
yeah,
the last mile step. That said, like, I use NX rollup as my build step for all of my npm packages,
mhm,
but that comes with some trade-offs. Like, I end up with like an index file, or I end up with fewer parts, so sometimes it's harder to tree shake it out or deal with things there. But the kind of nice aspect of it still being a bundle step is you have a bit more power versus just a one-to-one transform.
right,
Like I could say, oh, um, I want to eliminate these exports off of this, or I want to do some magic in the compilation step that would require broader knowledge of how all the pieces link together.
yeah,
But generally, I would say last mile builds, there's a different responsibility there versus um, the intermediary steps, like when I'm building packages. Ideally, you want to leave all that optimization stuff to the last mile and not, do it in your. So when like I'm using rollup in my builds, I'm churning off as much as possible to make rollup behave as close to Babel as I can, be as granular as
yeah,
possible. Don't bundle the node modules. Don't hoist the imports. Don't do anything you would usually do to try and like speed up parsing or speed up the waterfall loading.
right. Gotcha. Excuse me. Sorry, bear with me, folks. I did want to jump into some stuff in the chat here. So just first of all, hi to everyone. We're not ignoring you. I'm just trying to make sure we fall into the conversation. But yeah, Emily, hello. Thanks for joining. This is a piece I want to get into a little bit later. I feel like at the top level, um, Zach, there is so this is one piece I want to bring up is right now, like I have this understanding of bundlers, and I'm actually very okay with this being a very black box. Like I do want to go in and flesh out the like what's happening in there, like especially getting since I have you understanding like what the last mile looks like that's part of this black box, I imagine. But there is a part of me that really likes the days when I didn't even need to know about Webpack. I just need to know. Well, this is how I got started in web dev. Is I latched on to Angular at the time when Angular 2 had just come out, and so I didn't know. I knew we were using Webpack in some way, but like even the fact that Angular was using Webpack was not something I needed to know. I really like that for what it's worth. I'd love to see, the broader community go towards that again. Just like not to be dismissive of all the work you're doing, I feel like
Oh no,
the
by all means. I like a lot of my career, I have been striving to get back to the jQuery and WordPress days.
yes. Well, so that's a thing too. It's like this question, like, why do we bundle? Why do we build? Like, part of the reason we're in JavaScript, I feel like, is because you can just send text to the browser and it will work, you know? So like, why are we even doing this to ourselves? Is like one of the questions. Like, we don't need to. We can just send out JavaScript to the browser and it would work. And we are humans, so we decide to put all this complexity in here because really, I don't know. Maybe that's something I could get your input on, but I do feel like we do come very attached to our input formats, and so being able to write our code however we want while still getting like very performant, very optimized output, is that kind of part of the reason for doing all this, or
I would say that, so I don't know, if I go back like 10, 15 years when I started getting into web
sure?
development, the way that I kind of look at it is like, how did a bundler become a thing? Like what, how did we end up in this position from back in, the glory days of
Yeah,
jQuery
like
widgets and
what the
like
hell happened?
WordPress?
Yeah,
Yeah, what happened? So, really, I think we can, the first thing that I had gotten into was like Backbone JS. That was like the first thing I did. It was essentially just taking like Lodash and jQuery and gluing them together. Um, and with that, you could do it with Gulp, and it was pretty easy to. Hey, give me one file that comes out, and it does all the things that I need. And you could and again, Gulp was more just like, okay, just join files together and maybe convert the format or something
yeah,
like
yeah, yeah,
that. But if we go further back, it was like, oh, in WordPress, you create script.js and then you just, dollar sign. And at the top of the header, you would put your jQuery tag and there you go.
yeah.
Um, and so,
Well,
I think,
could we try to maybe like tier these? If I don't know, I'm a nerd, so I like classifying stuff. But like, what is first generation bundlers? Is that where we bring in like Grunt and Gulp? And like, do we put Babel in that category here too? Or how would you
trying to remember
maybe?
when
Yeah,
when Babel kind of came into focus.
we can
'Cause I
look
can't
this
even
up
remember.
too.
So I think prior to even Babel, I was just using like Gulp and Grunt, but I don't like the actual history might be a little different. But essentially, if we're thinking like first generation, these are the kind of first things that I would use. It would be Gulp and Grunt and Babel, either together or not
Sure.
together.
I'm just trying to
And there's
see if
really,
there's ways of us like being able to identify when these things became popular. So this is Babel right here. We can throw up like Grunt and some of the others here too.
yeah, let's do it.
Grunt.
Let's see.
So it's Babel versus Grunt. I think maybe just before 2015, we just don't have data. But
Well, I think this is when they started to appear. Like I know Grunt
yeah,
came out around 2015, and I started working in dev in like 2010. So kind of back then, or no, Grunt can't have been 2015. It had to have been earlier.
yeah.
Maybe it was
We must just
2015.
not have data before then, or just npm. Were folks not maybe using npm as much back then?
Oh,
I don't
that's
know.
right. It was Bower back then. Before then, it was Bower. Remember Bower install?
Right. Yes, I do. Man,
So
we're
so
going
yeah.
way down
So
memory lane.
kind of start out
I
with
think.
like Bower and maybe Composer, and usually in like your
Wait.
PHP app, you'd have the Bower.
So Bauer like almost like a package manager,
I mean, it was essentially another version of NPM. Like that's how
right?
I remember it anyway. Was yeah, was this this like I mostly lol and even use npm install Bower nowadays. But yeah, so it used to be Bower, and like that's what you would maybe I would use that with like Composer for PHP sites. So I think this is
Right.
kind of when bundlers started to become a thing, is when we left the, oh, everything's a jQuery widget, I can just get off a CDN and just plant another widget at the top, or just download the script and manually copy it over. And then it was like, oh, well, we want to install things from other places. And so when we got into that step of, oh, well, now I want to install stuff, then it kind of became important of, oh, well, now I need to kind of resolve it, or I need to pull those
Yeah,
text files out and pack them into something else. And that's
yeah,
kind of, I think, where like Gulp and Grunt started to become more popular as things, as we got into the point where we're getting things from a third party, and it's not just get it off the zip file, or it's not just,
yeah.
Google's CDN for all the popular jQuery things. When we
Yeah.
stopped just linking to things directly and we actually need to install it, that's
Yeah.
when I think the compilation phase started to become something we had to do.
Yeah. 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 So we're getting to a point. So, yeah. Yeah, Mike remembers using just make. Yeah, I used make way back in the day for his like C stuff. But but yeah, um uh there's just so much stuff to unpack here, I feel like. Um yeah, I don't know. Zach, I'm sorry, I'll just let you keep going.
But yeah, this was kind of like the first generation we needed stuff, like Bower using like some kind of task pipeline to glue it all together.
Yeah,
I honestly don't remember what Browserify was, but I remember using it because this was like so
yes,
back in the early days. So it was like, my colleagues would set up the Gulp pipeline and then I would
yes,
get my hands on it. But I thought maybe Browserify was kind of the thing that made it one file. I
okay.
honestly can't remember like what it did. I can't remember if it was just polyfilling stuff or if that was what kind of made chunks. Because I remember using Browserify to like get like live reload to work or stuff like that. So I'm thinking maybe that was kind of the early era of, oh, well, now with all the Bower components, you would kind of use Browserify with Gulp and with Babel and now you can kind of see, oh, well, these three things, we start getting into the filter, which was Gulp, we get into the transform, which was Babel, and then possibly Browserify, that was the module type conversion. And so all three, you would kind of, okay, cool. Well, all three of these individual parts more or less came together to create a primitive kind of bundler from like the sum of parts. If Browserify was that, honestly, it was so long ago, and I never even looked into what it was. I just knew I had to put it on there, and whenever Browserify was there, then early days HMR would work. So I'm thinking Browserify must have been like had something to do with kind of giving us that better output approach, but I might be wrong. Okay, okay, there we go. Yes, okay, my assumption was right. I honestly never used Browserify. It was just in Gulp, and like it was somebody else. Or you'd go and get like a template where it was there. Oh, you're muted.
Thank you, Zach. Thank you. My experience with all of this was just like I was aware of these things. These were like off in my periphery, and I was like, man, it must suck to do that because I was just here. I was happy with this, and then I needed to go from like Angular is going to spit out like a directory, right? And then I needed to figure out how to host this on like a Tomcat server. So I needed to
Oh,
putting it from
Tomcat.
yes,
Going way back here. Okay.
yeah. So I was like, well, how do I do that? And I needed like I forget what even the format was. It was something like web something, some format. I needed to take that and turn it into it's just what I don't know if anyone can help me out here. It's just like the package that like most Java stuff would ship out in. It's
Like
like
a
escaping my
Maven or
memory.
not a jar,
Not the jar, but like the
I know
like
what you're talking
the
about.
artifact form of a jar, essentially.
Yeah,
So
yeah. It was like a virtual file system or something. Like you'd mount
yes,
that thing, and then there's like a virtual file system in there where
yes,
you
yes,
could then
yes.
have everything. Yeah.
So I had Angular getting me to the point where I had the files. And then I was like, how do I get this to, whatever that format was? I don't want to learn any of it. So I was like just going through packages that did that stuff. And I ended up pulling in Grunt for no reason other than I think Grunt's really like just a task runner. I don't know. I
Grunt
haven't
and
used it
Gulp,
very
they're
much.
almost the same thing. The only
Oh
difference
yeah.
between Grunt was like it was like JSON oriented. So it was
Oh,
like, oh,
okay.
well, everything's like a folder structure and a JSON file, and you couldn't really script anything. You'd have to create another JSON, and then that
Okay.
JSON could like link to a script, and then the script you would write it in, but it was really rigid. So it was
Uh-huh.
like, okay, Grunt came out, and the pains of like dealing with just JSON-based building,
Yeah,
we kind of
just
saw the
static
problems.
data instead of like functionality. I can
And
imagine
then
that's
Gulp came along, and Gulp was like the big revolution, at least in my head, because then it went, oh,
yeah.
wait, I have this whole piping capability. I can take, you know, images and I can pipe it into a piece of JavaScript that could turn it into base 64, and then I could pipe that into something like LZMA, which could then, convert it into like a blob of some kind.
Yeah.
And so Gulp was really great because it was, I would say Gulp was like the beginnings of this kind of primitive way of doing like the omniscient view. Gulp didn't, like, each task didn't know anything about the other one, but you could pipe them together in a way that they kind of did. Um, but yeah. So like that's kind of what we started with was yeah, was the virtual file system. The piping was really it. Like the piping was changed everything because then I could go, oh, now I could create like complicated transforms. It could start out as something, go through 20 things that I could control, and then I could create some kind of output format. And at the end of the pipe, it would be, Browserify. And Browserify would be, again, like the very first version of bundling. I don't think Browserify even had the concept of chunking. It was more just cool. Give me a main JS or an index JS that has the sum of the parts in there.
Yeah. Well, okay, let's take a step back from the history of bundles real quick because I wanted to get this down and just like generally like what the steps in the builder are. So I heard mention like filtering is a step. There's like
Hmm.
the transform step, obviously. I feel like that's the
Hmm.
big one. Or that's the one that comes to mind for me generally. Um, and we've talked about sort of a last mile. So I'll add that in. Like this is like, I don't know, the last one, but last mile. What else would there be? What am I missing right now, Zach?
Then it would be three would be the module type conversion,
Okay, so
which would be
that
kind of
is
what,
itself
maybe
a thing.
Browserify would do because whatever you would probably be importing common JS or whatever Node, yeah, common JS because it's what Node understood, but the browser doesn't know what module.exports is. So you would need to have the type conversion. So that would be, if we were to look at this in terms of like a first generation bundlers, filtering would be Gulp and Grunt, and then transform would be Babel, and then Browserify would be type conversion. And then
Mhm.
there's like your primitive thing to that combined would make the bundler.
Right, right. So this is first generation in terms of like these things are like most people are putting these things together. Was Browserify like step number three kind of or
It was kind of a bit of both because I think at this time there
okay,
wasn't really any module types to convert. We had things like UMD and whatever, and so it was kind
right,
of just like so Browserify acted as last mile, but last mile was a very primitive term. So
okay. Well,
type
so yeah,
conversion was essentially going to last mile. There wasn't
gotcha.
anything like, oh, well now it can handle UMD formats or something like that. You would crunch everything down into like one format.
Right, right, right. Cool. So, oh well, this is really exciting because I feel like this is at least for me really helping to flesh out kind of what's going on here and what was happening, the whole time. Maybe we do like this is like if we make like some sort of graph. I'm sorry, this might break down, or we might be doing this for nothing at some point. But I also want to make like a grid here, just
Hmm.
to like first generation, second generation, just go from there. Um, if that makes sense. And so we'll just say like this. And we'll say so. Here's first gen, and then what is second gen? Would
So
you in
second
your
gen
mind?
would probably be when we got into that the second gen would be like Webpack because
Okay,
essentially like I believe the reason that Tobias wrote Webpack was I think it was like for university for something he was doing. I think he was like writing his thesis or something, and he was trying to build some kind of like web thing, and he was really frustrated by like oh the like oh it's such a nightmare just to get the artifacts here. I had to keep track of the images and have to put them in a certain folder and like get all the paths right. And then if the CSS was here and every it was the problem of oh well nothing actually understands each other, so like I have to load the CSS separately from the JS. Like I don't
yeah,
think
yeah,
back in with Browserify and stuff, like it couldn't really handle CSS, or maybe there was like some hack to do it, but there was no graph for CSS. So it'd essentially be you create your JavaScript, you drop it at the bottom of like your WordPress site or whatever, and then you would build your CSS separately in Gulp or Grunt, and then you would,
yeah.
have like index CSS and index JS, and then you would put that in your head manually, like hard coding it, and then you would put another one in the bottom, in the foot for the script tag. And
What?
so that got really annoying to manage all the asset parts and get them
Yeah.
together.
I wonder is should that be considered like another step? Is just like dealing with non JavaScript assets, or
Then we could probably put like a. I mean, I would still say that that's the module type conversion technically because
okay,
because if even how CSS works, like if we're looking at say like how Webpack does it, Webpack's evolved a little bit more now since like Webpack 1, but back in Webpack 1, all Webpack was just essentially like really fancy string replacement with a bunch of regexes. So the whole
right,
bundling phase was just really complicated regular expressions that would switch and replace strings. And even today, still a lot of Webpack is just fancy string replacement.
yeah,
Um, but you know that was kind of the magic of it is oh I can add CSS loader and CSS loader would take a string of CSS and would convert it into a string of JavaScript that had a side effect of creating a style tag in the browser when required.
okay.
So when the
Well,
module was loaded, it would just style tag append a giant string of styles.
right. So is this kind of, well, first of all, maybe the image as I'm presenting is kind of like first gen. We had all these different tools to build up the different things that we were thinking as bundling. Second gen is just Webpack gets dropped in and does kind of all of that. But then you also have like the idea of building an ecosystem around bundling too, with like the idea of plugins with like CSS. So maybe that looks like a smaller like Webpack specific plugin to
Yeah, with
support
like
that
plugins and
ecosystem.
loaders that help with the putting it into JavaScript, and then the bundler understands that there's side effects associated uh, with certain things. But effectively, and even today, like how most things work, I think now that we're getting into the Rust era of things, it's changing. But in the second gen, it was take everything, convert it into JavaScript, and then treat it all as JavaScript, regardless of whatever it was.
Oh,
Maybe if it's an
interesting.
image that you want to load, back in the days, it would be you would inline it. Oh, base64 it, and there you go. And then file loader came out, and the idea was, okay, just output the file as it was, and the JavaScript part is just a link tag. So if it's an image, it would be okay, just pass through the image and keep track of the file name and then make it relative to the script tag that comes out. So when I import the image, what I'm actually importing is a string, and that string is the file path. And
Yeah.
so image source equals import would become just, slash dist slash images slash, logo. And
Yeah.
that was kind of, but still it was that whole idea of like linking it, being able to have something that understood where everything was.
Yeah.
And
So like
to Webpack, importing an image was still JavaScript. It was just the module exports was a file path.
right. Maybe that this is a question that's coming up here now that we're talking about like second gen stuff because um well, I guess I need more clarification on this just for my own understanding, I think. But we've kind of talked about like you've dropped now the term linking. I want to kind of get into like what that is a little bit more. Like, is that fitting into this kind of stuff? And the other thing I
I
really
would
want to understand
imagine,
is like chunking and how those
yeah.
things relate because I,
So
I feel like they probably do their hand in glove kind of, right? So
yeah. So chunking, I would say, was something that came up in second gen, and that
okay,
was kind of where that falls what I would consider under last mile, because
okay,
now we're starting to split it up and shard it into parts that are more efficient or more optimized.
right.
Um, And so yeah, so loaders and plugins are kind of type conversion, and then you would get into like what was it called? Uglify and chunking, and that's the last mile aspect.
Okay.
Reduce the sum of parts, and
What is
y-
Uglify? What is because I
Uglify was
remember
the
seeing
old
that.
school Terser plugin. So it was essentially like minification or
Okay.
obfuscation or compression, making the build go from y- big variable names to little
To
variable
just
names.
right, but
Yeah.
not necessarily human readable. But
Yeah.
I was always curious about that because I would always see, like again, coming from the Angular world, you'd see that term come up inside of the build and like uglifying it now or like minifying or stuff like that. And I was like, wonder why it's doing that. And I was like, oh, obviously, we're taking a very big thing with all the names that I use because especially back then, I really liked long names coming from like the Java world. So my variables were like really big. And then you see, okay, what gets spit out? And you're like, oh, this is just the same stuff. It's just instead of that really long name, like obviously they alias that to A or B or something like that. So that made sense. Was there ever anything with like uglifying it that was like, because when I saw uglify, I assumed like we're trying to obscure what the actual source code was so that you could get back to like whatever that source code was, which I don't think is actually the case. But that's what my like junior dev mind went to.
I mean,
But was that
that's kind
ever
of
a
where
motivation
my
to you?
head like I think in the early days that was a lot of how I don't know, like the people that I spoke to anyway, I was like, oh well, uglifying it was like a security feature, or you'd obfuscate the builds, nobody could read your source directly.
Right.
But obviously as tech got a little better, it became very easy to just reverse engineer it and
Right.
you know reverse compile it back into like something easier to read. But
Yeah.
it was a mix between like I think that's kind of how it was kind of pitched to like the back end architects at the time was, oh look, it obfuscates the code, and then it was like, oh yeah, well it
Yeah.
also like uh
It seems silly now, but I
minimize.
swear I
Yeah,
really did think that was the thing back then. Which
I
like
think that
I
was
don't know.
probably like the that's how I remembered. It's like, oh, you do it as like, to make it harder for people to reverse engineer your site. And then it became more, oh, well, it's more like to reduce the payload that you're sending. But
Yeah.
yeah, like the early days of it, I think that's how whenever you pitch it to backend devs or, somebody, it would always be like, oh, well, look at this feature. It makes it more secure and the size gets a bit smaller. But we weren't really that focused on size back then. I don't
Right.
think things were large enough for us to care that much.
Interesting. Cool. So there's all this stuff that's coming in. So the idea of chunking, I think that's one I want to get to specifically, just because this is like my understanding is this is where we really start taking advantage of modules so that we don't always have to send everything to the browser all at once, right? Is that the motivation for chunking? I would think. Um,
Yeah, so this I think
uh,
in the back then it was like how the early chunking looked. I'm pretty sure was like it was essentially just like you could create multiple entry points. I don't even know if we had like the split chunks. No, we must have had split chunks 'cause I remember creating like the vendor function. But yeah, so
what
chunking was like
is
a
a
way
split
to
chunk? That's
so split or chunk splitting back in the day, it was pretty much like a, oh, I have all these node modules and I want the caching to be better, so I could move it all to vendors because I never update my dependencies, so I don't need like uh, you know Lodash and jQuery because and Backbone JS, like I don't need the hash to change and me to re-download it like with main. Every time before, you'd have to download everything because it would change the hash and you'd invalidate the whole file and all of that.
gotcha.
So then chunking came along, so you could say, oh, well, the things that never change, the browser can hold onto that cache. So if I didn't
Mm,
update the 5 dependencies I had, then you would be able to re-download that, and then the things that did change, like your source code, would be in a separate file, which could
interesting.
change
Yeah,
separately.
yeah, yeah. So like most of the time, there's these pieces of your app that just don't change, and so you people their users are obviously going on there, so their browsers are caching these different files because they've seen them before. We're wanting to take advantage of that so that when people do bring in the new stuff, it's only our new stuff because, like you said, I guess I remember this idea of the vendors directory too. That's not something I don't remember when I stopped seeing that. I remember seeing it at some point and then like not seeing it anymore. And I guess like a lot of it comes down to that. It's just like I don't know,
Yeah.
having that idea of well, here's our imported code. Maybe as npm became more ubiquitous inside of the thing, we're just like that's just it
Yeah,
is
like
no
vendors
modules.
is usually where I'd like go and download jQuery myself and I'd drop it in the vendor folder and then maybe you'd have like a gulp task that would build the vendors and as a separate build. It was, kind of the separate entry points of things. And then Webpack came along and could say, oh, well, we understand where everything is, so we could just say, here's a regex like node modules, and you could say all your node modules, anything with the path node modules or Bower components, that becomes the vendor chunk. But you could do it from one build graph, kind of.
Right, right, right.
And we had mentioned linking a little bit before, and I did want to like cover like what a linker is. But
Yeah.
a linker is nothing new, and kind of I believe everything Browserify probably had a linker as well, and every compiler has a linker. But all a linker really kind of is, it's kind of like, okay, well, there's resolving and then there's linking. So resolving is, okay, you asked for the file, and now I need to find where it is on the file system. So if we
Mm,
think in like maybe in Python, um, the resolution step is like really weird, and it's kind of, related to like a where.
Test. Oh no. Let's see. Um, hello, hello. Zach, are you there? Oh no. Technical difficulties. I don't know what's happening right now, exactly what people are seeing. I think my internet went out. Zach, if you're there, give me a sign. If you can hear me. Frozen lock file. Hey, I think people can see me now. Can someone give me something in the chat that folks can see me? Um, let me see if I can message Zach. There he is.
I'm back.
Hey,
Sorry,
I
I
don't know
think
if
my
that was you
internet
or
dropped
me.
or something like that. I saw Zscaler disappear and then Zscaler reappear, so I'm guessing like some endpoint protection just updated and decided to restart my network driver. But cool,
Gotcha.
okay, I'm back.
We have way too many jokes in the chat.
Uh,
That was
but so
great.
I think I thought maybe yours had dropped, so I was like
It,
talking on the stream until you
yeah.
popped up, and then I'm like, and then it said, I think your internet's off, and I'm like, okay, let me reload the page, and then I see Zscaler disappear and reconnect.
No,
But module resolution, that's always been a thing. But like, I think in Python it's like that weird kind of directory structure, and it kind of depends on where the Python packages are kind of stored. The Lark VPN. And then and then like a good way, I think one we'll all understand is like the node module resolution. So when you require
right,
something, how module resolving works is kind of like, okay, go from where I am and then recurse upward
right,
through for the next parent of the node module, and then check if React is in that folder, and if not, keep going up and then check every node module for uh, until you find like what they're importing and you've resolved it.
right.
And then when it's like nested packages, like if
Well, I
if
think just like
Backbone.js imports Lodash, Backbone.js folder in node, it'll be node module slash backbone slash node module slash Lodash. And then,
right,
Yarn came out and did hoisting to kind of make it a bit simpler. Um,
right. Well, so I think part of this too is just like going back to again, like thinking about the input format versus like the output format. The import format we want to work with is like when we import something from a file, we use a relative path from like the current file. But that's not always going to work when we put it to the output because well, I don't know, like part of the bundling may be like, hey, this file as we see it here, as we're working with it here, that doesn't exist in the output. So how do we build those modules? And like, how do we, when we import from a file, how do we know where that file is going to be? Is that kind of what the
I would
idea
say
of
that's
linking
probably
is?
where the linker comes in. So like if we think of like the ESM linker, it's
Okay.
essentially okay, so we parse everything, we figure out like where it is in terms of so we have the resolve, which is okay, look at the paths and then walk the paths and find it. And then once I found it, the linker is kind of like, okay, so what's it using in here? This export goes to that thing, which gets exported back out here, or the linker and the parser might kind of work in tandem in some ways where you do your parse step to find things, do the link phase, then do the next parsing phase, then do the link phase. And the link phase kind of just connects the dependencies to say, hey, they're ready to go. Um, in terms of like
Gotcha.
on the output format, I would say probably linking comes into focus there because that does influence where the chunks are because you need to know, okay,
Right.
well, I need to know like who depends on what. So I need to build up a graph to actually know like, okay, well, which pieces link together so that I can create the output format. Resolving
Mhm.
is like a little earlier on in the step of saying, okay, let me find all the things that I need
Right. Okay.
first so that I can then link to them. And then bundlers use resolution and linking to then yield an output format, kind of.
Gotcha. That makes sense. Cool. Cool. Um, I guess, yeah, maybe can we go on to the next gen? And maybe like one of the questions here would be, why did we ever leave this? Because I do have fond ideas of this, I guess.
Um, so I think so in third gen, this is probably where like I would say like Webpack 4 starts, to just kind of put a so Webpack still goes from second to third just because it's been around for, a very long time. But then we also had things like rollup and uh and maybe I mean ES build is pretty new, so we could probably say that that's like maybe going into the fifth gen potentially. Um, but in third generation, I would say we have like still Webpack, maybe rollup appears, and then maybe we say like a parcel shows up in here. Um, I'm not sure exactly when, but I know a lot of these are like newer. Like Webpack was essentially one of the first, and then a few other things popped up. But I think kind of the reason that we kind of got into, maybe yeah, I would say like maybe the reason that we kind of left the Webpack one, like why did more things begin to emerge? I'm not 100% sure why, because like I have always just used Webpack. Like since I went from Gulp to Webpack, and that's essentially my developer evolution, and then to
Right.
Rspack. But I mean, that's just the
Right.
Rust Webpack. But I think the other ones kind of started to appear mostly because um, configuring Webpack has inherently been a very complicated process.
Yeah.
It's reminiscent of the Gulp. Of the grunt-like configuration, very verbose,
Okay.
very fine-grained control, and a handful of people actually knew how to configure Webpack. Like, I don't know, for the first maybe two or three jobs that I got, like my first job in the US, I got it. I went in to do the interview, and it was like, okay, build a to-do app. And I had like 45 minutes to build this to-do app, and I spent maybe 25 of the minutes reconfiguring their Webpack build because it was so atrocious. So I went and like it was still using like like Watchpack or NodeMon to just restart a dev build, and I'm like, okay, no, we got to get the code, we've got to get the HMR implemented. Oh, web rollup implemented tree shaking before Webpack. I did not know that.
Yeah.
Oh,
So
okay.
Emily also,
In
I
mad
think
respect,
Emily is
I need to
putting
follow you on Twitter.
I know. Emily's been super helpful here. So Emily was putting Veet over here. I believe she was meaning to put it in third generation, which is interesting. There's actually something I want to get
Well, it's
into
because
this
Veet was
too.
Veet was. Mhm.
Oh, sorry. Go ahead, Zach.
Would Veet be third? Because Veet came out in what, like 2020, 2019? Okay, I guess
Yeah,
we could say third gen. Yeah, let's just put it
I
under
have no
third gen so we
idea.
don't get more
Uh,
complicated.
Maybe the question would be, what is the difference between second and third gen? Is it just as time passes and
I
Webpack?
mean, so it sounds like what we're seeing really is that optimization started to become a thing, like from Emily's input here. So second gen was
Yeah.
okay, cool. We have this asset pipeline that's now manageable and everything's yeah, Veet, I'm
Sure.
pretty sure Veet was a 2020 thing that popped up.
Let's throw it into
Because that's when
fourth
ES
gen.
build. Okay. Because
Yeah.
the fourth gen, I would say this is where we start getting more like native stuff coming in. Like when we
Yeah.
stopped building JS tooling, and then ES build came in, and then Veet is a combo of ES build and rollup under the hood.
Right.
Um,
That's
uh,
that's one of the things I want to get into is it feels like what is a bundler? Like in second gen, I understand. Like it's Webpack, got it. But now,
yeah,
like going
and
into third
yeah,
gen, I think these things
yeah.
are starting to become maybe more nuanced and more like niche
I think
almost, if that makes
so.
sense.
Third gen, so maybe even Webpack, maybe in third gen, maybe that started like Webpack V2 potentially, maybe V3, but essentially third gen is kind of where we need. Let's just call it from like Webpack V3 to be safe. I think that's when it stabilized. So I would say this is where we start getting into like code splitting and tree shaking, and at this point, it's not just oh well we just need to take a ton of JS and just make it easier to manage, but it's like okay well actually the apps are primarily being written in JS. And now we need to start thinking about dead code elimination. Now it's getting too large. It's not just, oh, we need our, 100 kilobyte backbone app, or we need to take like a slick slider and combine it with like some other little tiny script. But now things
Right.
start getting large, and we start getting like 20 megabyte apps or something. And so third gen was like, okay, well, we need better last mile outputting, essentially. Like this started to become focus because the shift happened from we need something to help us manage a handful of scripts that go on like a Java or a PHP or something like that, to oh well, now we're building things in with Node.js as the backend, and the whole app is end to end written in JavaScript or close to it. And now we need better optimization. We need to, you know, we're starting to
Yeah.
realize, oh, well, maybe, doing everything in JS isn't the perfect thing. And we need to start like reducing the size of it because it's getting unmanageable. So I would say this is
Right.
really where we start getting into more last mile, taking focus into how we think it today.
Okay, cool. So with rollup and parcel coming up, these are more like my understanding at least is rollup is something I would use for when I'm building a package, but I don't think I would necessarily reach for it if I'm building my web app. Is that right? Or like are these things starting to arise for
It
like more
depends on
specific
who
use
you
cases?
ask.
Okay.
It depends on who you
I don't know.
ask, because
This
this
is
is a
just what I
very
happen to do
contentious.
just because that's what I've seen. So I'm trying to like unpack
Well, so
all
this
those
is how I
things.
kind of this is kind of how I view it as well, is like, okay, I'll reach for roll up for like the intermediary parts, the non last mile things, but
Hmm.
Vite production build is roll up, if I'm right. Yes. Yes. Yeah. Vite's production build is roll up. So, you can use it for the whole thing, but in general, my like the main reason that I don't use these things for the last mile is I want the flexibility. And for me, my whole obsession is, and it's very controversial, I would say, especially now, like we have kind of the purist movement of, well, everything should be ESM, or we hate bundling because it's like super complicated, blah blah blah. Um, and we want to go back to just plain ESM. But the problem is we still have the problems we had that made us even create bundlers back in the day, which is it's like too many network requests. And yes, we love the new input format. We don't need the bundler as a developer, but you need the bundler if you want to retain revenue and users. And it's like bundling is effectively not a developer thing. It kind of is, but with ESM coming out, oh, well, technically you can do most of it with maybe just a slight transform and just all in ESM.
Yeah.
But the reason we're still bundling has nothing to do with the developer for the most part. It's a business function. It's to
Yeah.
make the end user get a good experience, not necessarily us.
Yeah. Well,
But yeah,
quick question, maybe Zach. Like browsers can handle ESM, right? Like they can handle an import statement, right?
yeah,
So
yeah,
okay,
they can, but the problem is it's the granularity of it. So the ESM doesn't have currently ESM doesn't have a specification for chunk. So that means
oh,
that for every module you have, for every import you have,
you're
and
coming in a
now
little garbled,
as
Zach. I'm
that
sorry.
gets larger and
Could
larger,
you
you're going to have a
repeat?
very big.
Sorry,
Okay,
you're coming in a little bit
maybe.
garbled. We can actually hear you all right now.
Okay,
Could you
yeah.
maybe
So
repeat what you were saying just about browsers can handle ESM, but there's like a granularity issue, I think was what you were starting to say.
yeah, browsers can handle ESM, but the problem is currently there's no concept of chunking in ESM. There's a proposal for it, but currently it's not rolled out. And even when the proposal exists, we're looking at, 5 years before you could actually utilize it as a native solution, maybe 5 to 10 years. That's generally the latency that we've seen since, I don't know, 2019 is, well, I don't know. I was speaking
Jeez.
to Tobias about ESM back in the day when we were implementing Federation into Webpack, and this was
Hmm.
when I think maybe Vite had just popped up, or we were getting into the, oh, let's just use pure ESM, and so it asked Tobias, hey, what's your view on ESM? Why has like Webpack's ESM thing not been a big priority up to back then? And his reply was, just, well, there's still 10 years before you could actually consider using it without quirks and without shims and polyfills. So there's no point in focusing on a problem that's only going to be solvable in like 10 years time. And this was
Yeah.
like, maybe back in like 2018, 2019. He said like, 5 to 10 years. And cool, here we are coming into 2025, and now like we're seeing 24, maybe things started to kind of tick over. So we're within the window of his estimation. And even then, still, you've got old Safari things that have quirks with it and don't quite work, and so on. So, probably in 26, it would be really, everybody who has a device would have a ESM capable device. But there's this really
Okay.
long latency on it.
Right. Right.
And
Right.
even then, the reason, yeah, you can ship ESM to the browser, but every import you have is going to be a new file you must download. So
Right.
if you have 100 imports, that's 100 network requests. And so the problem we're getting into is, yeah, you can load ESM to the
Yeah.
browser at the expense of a massive waterfall that's going to form.
Right. 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 So this kind of goes all back to this. I feel like it's like, yes, we want to do all these things, but we need to be able to support at the end of the day. Like we want an output. We want an input that looks exactly like we want, while getting the
We want a
output that is
developer-friendly output with a user-friendly output.
right. Well, a
And so you still need
developer friendly input, right?
yeah.
Okay, cool.
And so the you and now the so you can so like what Angular does is they just output ESM, but it's chunked ESM. So there's some custom chunking format, or something, there's something that kind of wraps it, that shoves more exports into whatever, and then relinks those exports to the thing you want. So maybe it's exporting, it wraps in a whole bunch of iffy functions, or something to that effect. So there's a bunch of
Yeah,
exports that are kind of encapsulated in some kind of way, so that React and React DOM could live in one chunk, and I could have two exports, one the React export and one's the React DOM export. And that's not
right,
vanilla ESM the way that we think about, or unbundled if we think about it, where, oh well, it's just everything. But the problem is everybody was like, oh, HTTP2 will fix everything. And then we found out that no, HTTP2 doesn't actually fix anything.
right.
Because on paper, yeah, HTTP2 can handle a lot of concurrent downloads.
Well, I don't even understand that piece very well either. Like HTTP2, is that what is the difference of HTTP2?
I think the main thing with HTTP2 was it just meant you could handle multiple requests in parallel. Whereas the
Okay,
one was like very much okay, like maybe that you could handle a few in parallel, like I don't know, maybe like four or something. So it would go in like batches of four. And then HTTP2 came out and you could do, hundreds in parallel. The problem is though, like if we look at ESM, there's sure there's other things in HTTP2, but if you just like, blanket it, it would be okay, it was able to handle uh, more requests in a more efficient manner. And you had things like streaming and, a couple other cool things that came along. But the way that I generally think of it is okay, you can do more requests in parallel without it slowing down too much.
yeah,
And so HTTP2 was, the thing. It was like, okay, oh, is it refreshing again?
yeah. You're coming in a little garbled, but we can still hear you right now. One of the big things I was noticing from this was just 9 years ago. Like, I don't think we're still, it's not like this is commonly used. Yeah, Lois. The chunk was split. Um, and also like superseded by HTTP3. What is this? I have not even heard of this. Yeah, HTTP 1v1.1. I think. Hey
Okay.
Zach, welcome back.
Clearly something's not liking me
The
today.
internet gods are not smiling on us. It's all right.
I've quit WebStorm, so it should magically become better now.
Nice.
um,
Freaking web store,
okay.
man. Let's blame that. But the big thing I was highlighting to folks while you were gone, Zach, was just 9 years ago. I remember hearing about this, I think when I was in college, because I graduated college in 2015, December of 2015, remembering this is going to be the new hotness. We're still not really using that, right? Like most people are not using HTTP2. So like going
I
to your
mean,
thing
we
of
kind of
the
use
the
it, but we're
lag.
not necessarily using everything from it. But yeah.
Gotcha. Well, also this, I had never even heard of HTTP3. Um, so
So three
I don't
is
know.
now even faster, and it reduces the latency further.
Okay.
This is where the Quick protocol came out, which is kind of what Chrome had used for a while. Um, The the big challenge that we kind of saw with HTTP2, this is kind of, I think, where Veet's idea came from of, oh, well, we could do unbundled and we could, kind of do that in development mode because we can send a lot of scripts and we can handle it more effectively. And a lot of devs also jumped on, oh, okay, well, hey, if HTTP2, then there's no problem sending 10,000 scripts to the browser. And yeah,
Yeah.
on paper, technically, yes, but virtually every browser has Chrome extensions.
Yeah.
And that's usually where I see the biggest pitfall is, oh, well, cool, it might be quick if you open incognito window, but drop an ad blocker on there, and then suddenly you're parsing every script on the way in, and then, real world network latency, and then the waterfall, because ESM, it goes by, cool, parse this file, see what we need, download that, parse the things we downloaded, see what they need, download some more, so you get this big waterfall that kind of occurs. Um, and then, okay, assuming that you could get the waterfall, so it's not just, oh, loading everything in parallel, but it's the fact that you only find things as you discover it. And then on top of that, even with that, the user's browser is still going to have a bunch of stuff that they put on it, and ultimately we find that that really does impact the real world performance of it. Maybe if the browser ships natively, it'll be quick, but as soon as you start actually adding stuff onto it from the user end, it has a significant impact on the real world speed. And this is really, again, why I'm still steadfast on you need chunking, because uh, it just doesn't work. Lots of network requests still don't work well. Did it freeze again on me?
Okay.
Okay,
That one
now I
was
have two
definitely.
copies of you. All right, all right. Maybe, let's blame StreamYard this time. There we go.
I think
um,
WebStorm got mad at us because Column didn't like all the WebStorm hate. Now
hey, I
listen,
love
Column.
WebStorm. I just know usually when I'm low on memory, it's WebStorm.
Yeah. Well, I mean, Column, if you're going to use JetBrains, at least use like the grown-up one. Like get what's it called? Idea,
IntelliJ?
whatever. Yeah, IntelliJ. There you go. WebStorm, I felt like I was WebStorm's where I started. It was my first IDE when I started in web dev. So I have a soft spot for that too. But I found out soon it's just the skin for like the all the other JetBrains ones. So why would you use WebStorm when you could use IntelliJ? I guess I don't know.
You're coming through garbled now as well. It's
No,
got to be there
I
now.
think it's both of us.
Now the buffer caught up.
Okay, good. Oh man.
But
Okay.
yeah, so like WebStorm's what I first started with as well. I think that's what you were saying. Like when you first started in
Yes.
development, it was, oh, reach for WebStorm, and then it was like, ooh. So I actually spoke to JetBrains about this because I'm like, well, why should I be using WebStorm if IntelliJ exists? So the main reason
Yeah.
they told me is IntelliJ is like the well-rounded one. It was, I think, initially mostly Java, but it has features for everything. But you'll have, if you do web a lot, WebStorm gets the web features first, and they trickle back down into IntelliJ, which is like, cool, the catch-all IDE. But that
Yeah.
was the official answer that I had gotten for the difference between them, and that's why I still use WebStorm over IntelliJ, because I first started with IntelliJ for that reason. It seemed powerful and could do everything. But apparently some
Oh
features come
shoot.
to
Okay.
WebStorm
Is this
before.
Zach or is it me? If there's anyone in chat that can hear me,
I can
give me
hear
a
you.
thumbs up,
I
I
can still
guess.
hear you. Are you able to hear me?
Oh, yeah, I hear you again now. Let's see.
Okay, I'm gonna say it's got to be StreamYard at this point because we're both having pops in and out on this.
Yeah. Zach, it was me that time. Okay. Good. We're both good now.
Okay.
All right. Well, let's try to get to the end of this
Uh,
chart and maybe we'll wrap up because the
okay.
gods are
All
not
right.
being
Yes.
kind. Maybe
Okay.
I'd love to have you back on, by the way, Zach, when we're not having so many problems too.
Yeah, we could definitely do like a step two on this and kind of get into, okay, well, how did these things work and so on. But I think kind of getting through the evolution of them here
I'd
is
be
good.
happy with that. Yeah.
So then we get into like maybe fourth, fifth gen. Yeah, we'll go with fifth gen now. And so fifth gen was really okay, JavaScript tools aren't quick. And Vite started to notice this as well, that building is getting too slow. And I think that was one of the main reasons. It was kind of twofold. Uh, People didn't like how complex building become, as well as I would say things got complicated.
Mm.
So something Vite did really well was in simplifying it, similar to roll down. But Vite really showed us, hey, things can be a lot less complicated, and they streamlined configuring a build. Um, the
Yeah.
challenge that we and also they sped up the development environment. They did that by using ES build, which was in between fourth and fifth gen, I would kind of say. But this is kind of where we saw, ooh, native tools, maybe this is the new thing. And then getting into fifth gen, this is where we see roll down, Rspack, and TurboPack come into focus, where we say JavaScript tooling maybe isn't the best thing for building JavaScript, and we start looking at languages that are actually faster.
Yeah.
And I think on
So
top of that as well, more integrated. So like the difference between Rspack and Webpack, well, yeah, they share the same API. Rspack tries to bake in a lot more sane options. Like you don't just configure it and then your build isn't really that optimized. Rspack like has its own chunking definitions built in. We have a parser for CSS kind of baked into it, and we have other things kind of already built in to provide more tools that are set up with better presets from the beginning, but we still provide a lot of flexibility that Webpack brought, mostly because in enterprise settings, uh, most large companies are still on Webpack, and the reason is, while yes, slow, there's nothing as robust as it, and that was the same constraint that we had, but we didn't want the slowness anymore.
gotcha.
And then
I'm
with
sorry.
roll down was effectively um, okay, well, rollup doesn't only understands ESM, and that becomes a major problem because lots of things are still in CommonJS. So you have to, and I don't know how roll down would handle like UMD or any of these other random formats that kind of came out. And that was one of the big things that Webpack did really well, is it was able to say, regardless of the input format, it could normalize it and produce a consistent output format. With rollup, how rollup works is if you have CommonJS, you have to have some like loader on top of it that converts the ESM, like the basic that converts the non-strict CommonJS back into strict ESM. And this causes a ton of problems in like actually reliably supporting the interrupt between the two.
Yeah, yeah. Makes sense.
And yeah, Rspack can be a hard sell because it's Webpack, um, but like at the same time, I think that like the way I think of Rspack is really the Webpack is two things, and this is how we viewed it when we picked it. Because before making Rspack start, we've written or under ByteDance, there were 3 bundlers that were produced, um, and and 4 bundlers in total written. So when the first iterations of Rspack were just an ES build plugin, um, and we basically took apart every build tool and rebuilt them in different languages to identify what works, what doesn't work, like where's the good and the bad of them. What we ultimately
Mm.
found was a lot of them, the failing point wasn't the API of the bundler or whatever they provided. It was actually the architecture of it. So it was like, oh, well, maybe we could just take rollup and rewrite it in Rust, or take ESBuild and rewrite it in Rust and fix like the bad chunking and the quirks and tree shaking and so on.
Hmm.
And, so that's what we first did. And then we were like, oh, wait, it's not actually that simple. Like, it's more the design of it is the problem. So, yeah, it works in its current form, but if you want to try and like fix the chunking and make the chunking better, you go off down this whole rabbit hole of, okay, actually need to re-architect the whole tool. And so when how we think of Rspack is we took the good piece of Webpack, which is Webpack's architecture. Like I think hands down Tobias is, I don't know if it's my bandwidth or yours. I see it reloading.
It might be mine. It's showing me that my internet's low, and I believe it actually right now. Just because my boys have been texting me that the internet's down for them. So probably me. If you can hear me, Zach.
Okay,
Shoot.
I think I'm back now.
Hey, welcome back.
All right, I'm just going to turn my VPN on and see if it's happier going through the office.
VPN. Okay.
Yeah, I'm going to turn it
Cool.
back on because it seems off. It's not too happy. So essentially, yeah. So Rspack and Webpack, there's these two, aspects of it, and the I can't tell if it's I see it going blank here, and I'm not sure
I
how
hear
to
you
change
just
it.
fine.
Okay, then cool. Let's just keep rolling with it.
Yeah, yeah.
There's two aspects. There's the architecture of Webpack, and like I think hands down, everybody could admit that Tobias is still like the OG when it comes to bundler design. Like I haven't seen a bundler as capable or as well designed as the stuff that he makes. Um, and that architecture has a massive amount of lifetime left in it. While Webpack is just written in the wrong language and is too verbose, the underlying design of it is exceptional. Like I would say there's nothing else, maybe TurboPack, but it only works with Next and still doesn't seem production ready, so I can't, make a call on it. But, the architecture of Webpack and its design is still the best that's ever been built up to this point. The problem, though, is it's verbose and it's complicated as an end user to use. So when so how we look at Rspack is Rspack so the Webpack part of Rspack is that the users think of and maybe what they don't like about it. Well, to us, that's the bindings. So Rspack is a Webpack architecture backend system. So we take a compiler and we use the architecture of Webpack, and then in V1 we create a set of bindings that is what the plugins and the loaders use. But those two are completely different from the architecture of it. So V2, we could just change the bindings file, and we could have a totally different bundler. So we already did this with, we took Unplugin's API. So I don't know if you know Unplugin. It's like a utility for, saying, okay, if I want to support multiple bundlers, I can use the Unplugin API, and it can, give me a standardized subset of an API that could work with ESBuild, or could work with Rollup, or could work with Webpack, and so on and so forth. And so what we ended up doing is we were like, oh, well, let's just experiment out with this. And what if we replace the bindings of Rspack and we used bindings that are similar to Unplugin's API? And
Okay.
so we did that, and we have there's a POC of it called Unpack. If you just Google it, it's under the Hardfist's GitHub, I think hardfist/unpack. And that's essentially us taking Rspack and what's going to become like the compiler SDK will create and saying, well, hey, here's the parts of a compiler. If you want a chunk graph and a module graph and a linker and a parser, and you don't want to have to build a new compiler each time, then here's all the parts that make up Rspack, and you can build your own bundler with the parts. So we ended up doing that, and we created like this Unpack thing, which is essentially 1/10 the functionality of Webpack, but it's 100 times 1/10 the functionality of Rspack, but it's 100 times faster than Rspack is today.
Yeah.
And again, it uses the Unplugin API, which is like 5 hooks or 6 hooks or whatever tiny API it's got.
Yeah. I'm having a hard time finding it.
Look
Where
up
did you say it was?
Hardfist. So look up the Git user Hardfist, or just go like
Um,
github.com/hardfist, and then we should yeah,
okay.
okay. So if you go to Hardfist there should be a repo under his
SpongeBob?
handle called there should
Okay,
be a
got it.
repo under his handle called Unpack. Um,
Let's find it.
yeah, and under his repositories there should be something called there we go. So this is the Unplugin API built on top of the Webpack architecture. So again, you see the difference here. Yes, Webpack, the way you think of everybody is like, oh, Webpack old. What they mean is they don't like that way of configuring Webpack. They're not saying that they have any if we made a new bundler and we shipped different bindings, like if we shipped Rspack, it would probably people would lose their minds. Oh, it's revolutionary, it's brand new. All it is, it's Webpack architectures with a different binding file at the top. At the same time, doing this, it's 100 times faster than Rspack, and it has 10% of the capability of Rspack. All the architecture's there, but the API is small, so therefore
Right.
it can't do a lot. But you could expand on the API if you wanted again, and that the only reason that Rspack is maybe slow is because we have a big set of bindings. If we reduce
Right.
the bindings, the thing becomes much faster. So it's the amount of things that it does and the size of the API we give to the user that's essentially the bottleneck. I think also this is what users, when they think of Rspack, they might go, oh, but it's just Webpack. It's like, well, no, it's Webpack's architecture, and V1 uses the bindings that matches Webpack's API. So all the
Gotcha.
users can now go from the slow Webpack solution. All their ecosystem mostly still works, but they're on a much faster, 10 to 20 times faster compilation speed. And then maybe in V2, we could say, okay, well, now we could ship new bindings. And those
Mm,
new bindings could then be, a totally different bundler,
right.
could be faster, could be much more streamlined. But we also have things like RS build, which is kind of what we tell everybody to use. And RS
Right.
build is to Rspack what Vite is to ES build and rollup. At the same
Okay.
time, people aren't just raw dogging ES build and rollup anymore.
Right.
We love Vite because it's really streamlined. Well, what they want is a build tool, not a compiler. They want
I
something
love
that,
this, by the
I want to
way.
use React, and then there we go.
Yeah.
And
I like the
that's what,
stars on the website as well. That's really cool.
oh, oh, my
But
wife actually did the design for this. So
nice.
if anybody's looking for a product designer, by the way, she's on the market at the moment.
That's awesome. I saw a
But
tweet
yeah,
about your wife. You're talking about like someone approached her and she asked them about she, I don't know. You could tell the story probably better than
yeah,
me,
it's
but
just that
that
someone
was
was
funny.
hitting on her she comes to some of the conferences with me, and we were out at somewhere, and waiting, like I was inside, she was outside like getting the taxi, and apparently like someone from the conference was hitting on her, and her litmus test for it was like, oh, they're like, oh, what do you do? It's like, oh yeah, no, it kind of explained kind of like why I'm here, like why she's here, why I'm here, what I work on.
Yeah.
She's like, oh, do you know Module Federation? They're like, no, and she was like, ah, okay, well, explained what it is, and then it was like, peace, and fades off into the background. Kind of became the litmus test for testing a dev in her mind is like, oh, well, do you know bundlers? Do you know what Federation is? And if not, then okay, well, fade into the
Yeah.
background.
She deemed him unworthy. Yeah.
Yes, deemed him unworthy. um,
Very nice. Well,
but
I
but
love I
but
love the
yes,
idea of like Thor here or yeah, RS
yeah,
build
yeah.
here.
And so this is kind of like when people go, oh, well, it's a port of Webpack or it's Webpack. It's like, no, it's not Webpack. It's Webpack's architecture, and if you use Rspack directly, it has that Webpack-like API, which makes it easy for big enterprises to adopt. But it doesn't mean that we're just going, oh, well, what does Webpack do, and just copy it
Yeah.
directly. It was more to reduce the cost for our own use case, where we have 15,000 repos, most of them are Webpack based. We want to speed them all up, and we need to keep change management at a minimum because it was
Right.
cheaper to build Rspack than it was to try and switch to a different build tool. Just to put it in perspective, the cost of economy of scale issue.
That makes
So,
sense.
what if the cheapest solution is to just take Webpack's bindings, develop a bundler with a solid architecture that'll meet all the business needs, and then make it really fast and cheap for the business to switch onto something that's guaranteed to be stable? And this was another big thing about why we did it was, um, with a lot of these bundles, like if you want to go and fix the problems with ES build or the problems with roll up, um, like if you wanted to add native CommonJS support to rollup or something, uh,
Yeah.
the big issue that you're going to run into, and this is what we saw, is like, oh, okay, but then we're back to bundler design and architecture
Yeah.
design. And essentially what that means is, yeah, it's totally possible, but it's completely unproven.
Yeah.
So
Yeah.
there's going to be edge cases, there's going to be race conditions, there's going to be problems that, well, if you're not a $400 billion tech company building this tool specifically for business KPIs, then yeah,
Yeah.
probably not an issue. But because this tool is designed, it's essentially a business tool pretending to be a dev tool. So the
Mm,
focus is purely enterprise metrics, things that a tech company would care about, which is going to be artifact integrity, the stability of it, how much mileage can we get for the business, how much flexibility. And so, again, if we have to go back to reinventing the wheel and designing a bundler, we're introducing risk to the business. Why
right.
not take something that we know has worked for this business for the last 10 years and is guaranteed to keep working? And what if we just put that in Rust? Because then what do we end up with? We end up with a very easy way to guarantee that there's no weird quirks.
Right.
Run Webpack's test suite on Rspack and check that the output Webpack gives is the same output that Rspack gives.
Right.
If that thing works, we know that the tool is solid and we've
Yeah.
skipped 10 years of pain.
Yeah.
And
Yeah.
then what
Yeah.
we can do from V2 or so on is we can say, okay, well, now let's iterate on and improve upon just getting
Yeah.
the test to
You kind of
work. So, like, the
have the
motto of Rspack was make it fast, make it work, make it faster.
okay.
We're now have completed the make it work period,
Mm,
which was make sure that the outputs are aligned. We know that what we have is guaranteed to work. There's not going to be any quirks. And then we can say from there, we can start to deviate. From there, we can start to bring more into it and not just make it a Rust Webpack. But
Right.
you can't do that unless you can establish a baseline. And for how we function and operate, that was the most economical baseline to set. Start with the
Yeah.
thing that we know will work and work backward from there, and it's a lot cheaper in terms of risk to a business.
Right. So like this equation that I have on here, what you're saying is like that is actually super important because you can take everything we have right now unknown that has been in here since like second gen, whatever year this was. This has been around for a long time. We know exactly what the inputs and the outputs should be. We're tying it all together here. We know exactly what the inputs, like what should be outputted. We can just say, okay, here's this, but oops, but let's make that faster. And so you
Yeah.
can say, okay, this is yes, these are provably the given this input, Rspack gives us the same exact output as Webpack. Proven, like that's a green, that's a whole test suite we can do with
66,000 unit
millions.
tests passing.
Yeah, yeah,
Like
yeah,
there you go.
exactly.
So that's the whole. I want to have something where I can take 10 years, millions of use cases, massive ecosystem, guarantee that what we build has a starting point of 66,000 unit tests passing, massive ecosystem on day zero, and then we evolve it. And that's a lot cheaper than entering the unknowns, the variables. Sure, if you're not if you're not ByteDance and you're building something, the world's your oyster. Start with
Yeah.
something, you can probably absorb more risk. But on
Mm,
our end, we have billions of users using these apps every day. Like think of this in e-commerce. Like in
mm.
e-commerce, you do everything around revenue protection, revenue performance. The web perf is really important, SEO is really important, all of that. Now, imagine, some of the world's largest applications. It's going to obviously compound the risk of everything. So for us, we need to make sure that a tool we build is going to work for, a quarter of the planet's population who's using all of these apps combined. And
That's
so
kind of wild just thinking about that. But yeah,
exactly.
that's
And so
crazy.
that's our risk profile essentially.
Right.
That's what's the most important above all else is
That's
ensuring
that's
that
really interesting, actually, that business needs are driving this kind of way forward. For like, I feel like there's kind of like splintering ways of going to from fourth gen to like this burgeoning fifth gen. So one is like the Rspack that you mentioned, and then there's like a clear path forward. I hear this. This is why I'm hearing from you, at least, Zach. So correct me if I'm wrong, but we have now like this provably faster thing that does the same exact output as Webpack, but now we can build on that to go from Rspack to RS build. That will use like
yeah,
the
this
same
is the early
engine
stages
almost.
of saying, oh, nobody likes configuring Webpack. Here's RS build. So if you like Fleet,
Gotcha.
you'll like RS build. But you've got the stability guaranteed by the whole how RS packs one, its architecture, so you're not going to have to swap it out in the future. Two, it
Yeah.
can do anything that we want. Three, all the test cases pass, and it produces really good, stable production artifacts. Um, and then because nobody likes configuring Webpack, here's RS build or here's RS lib, which is like,
I see.
us adding on to Rspack things that Webpack doesn't have to make rollup like outputs, really good input formats, because Webpack was primarily designed for last mile builds. So it sucked at making packages. Like if you try to, I want to create CSS that I can import in my npm package that then the parent bundler works at. Welcome to hell. Webpack will
Yeah.
always want to either do style loader or it's going to put like document append link to append the side effect because it thinks, oh, CSS, I'm the last mile build. I'll do the browser injection part. And I'm like, no, no, no. I just want you to treat it as an external. So convert it and then just put import from the .css file that you generate and let the last mile build actually handle the side effect of getting it into the browser. So
Yeah.
then rslib is us saying, let's add a new module format into rspack, which is called modern module, which is essentially ESM, but without all the wrappers that Webpack puts around stuff. So it's
Yeah.
closer to how like rollup emits an output. And we want to say,
Okay.
hey, there should be a mode that's very similar to unbundled, but you don't lose the power of the build tool, and you don't lose the power of that Webpack runtime that it has. But you're also not sacrificing your tree shaking, and you're sacrificing everything else to utilize it. So it's trying to strike that balance where we can have one tool that can do everything we need to do,
Right.
and that's kind of where, our variants go off into is saying, hey, yeah, Webpack's difficult to configure, has a super powerful API, but you should be using rslib or rsbuild, and only
Mhm.
if you're already on Webpack should you be using Rspack directly for, an easier migration over. Otherwise, if you come to start with it, just use one of these
Just
higher
grab
level
this,
tools. Yeah,
right?
and it's gonna have,
So
and then all you do is say plugin React output,
yeah,
and then you have like a very Vite style configuration, very
yeah.
streamlined. And Vite did that
That's one of the
exceptionally well. They
reasons
changed
why
the
I like
game
this
on
logo so
build
much.
config.
Yeah. Well, yeah, I love this logo so much because it's literally that. It's like, hey, we have the baseline. Here's Rspack, but this is Rspack with, the hammer, I guess. So like whatever that means. But like it's like you said, it's very reminiscent of Vite, where like we're going to change the API. We're going to change the way you write it. Like this exists and it has to exist to support like a legacy ecosystem. But we want to move forward, and here we want to give people the native APIs that they
It's
want
it's
for
it's
fifth
not
gen.
even a legacy ecosystem necessarily. Well, one, it's a legacy ecosystem or an ecosystem that we want to have, saying, hey, you can
Right.
use everything that Webpack had, and that's a really good starting point. But also, we need Rspack under the hood because what we want is the power of it. Because we need to
Right.
build things like apps for WeChat, and so WeChat apps are
Yes.
JSON modules, not JavaScript. So that means they need a bundler that could output not JavaScript but output JSON. So that's a totally foreign concept to most bundlers because they can only output like ESM or maybe something else.
Yeah.
So we have to, and also we have like native apps that we have to like build into. So we have a really broad spectrum of like business functions, and we don't want to have like 12 tools because most of the on-call pressure from the infra team comes from build problems. Now, if you amplify that by, oh well, we need like 5 different tools to actually build the apps in different ways,
Yeah.
the on-call pressure and the fragmentation comes a lot harder. Um, so what if we had an architecture and an API that was robust enough to do everything that we need to do, and then we can simplify this with build tools, not compiler. So compiler is Rspack, but the build tool could be rsbuild. And the nice thing with rsbuild as well is it absorbs any changes that we might make to Rspack in the future. Like when
Right.
Rspack v2 comes out, we might start removing some older APIs that are no longer like that bottleneck our build process, or things that hey, we could get rid of that, replace it with something better that is faster, so on and so forth. But effectively, like, and at the company, how we absorb that change is everybody uses rsbuild. So like modern JS is built on rsbuild. Links are our version of React Native, like our in-house React Native is a rsbuild plugin for links. Um, and it's called a Rspeedy when we open source it. But effectively now, if we change Rspack, all we have to do is update Speedy, RSlib, or RSbuild, and the end users don't notice anything's changed because there's a separation from the APIs of the compiler. So it gives you easier ways to navigate around, similar to like Vite. Vite should be able to swap out ESBuild and rollup with rolldown because Vite is the API layer. That's what the end user is using. So the build tools don't actually matter that much. And so that gives them a lot more flexibility to do that type of stuff, because as long as the upper end stays compatible, the lower end just needs the APIs to actually provide the user with what they need to do, and they can absorb the translation cost in the build tool itself. Similar kind of model that we've taken with Rspack is
Yeah.
make it fast, make it work, make it faster. And now since V1 is out, we're moving into the make it faster territory, which will come with toward the end of V1, so in like 18 months time. That's when we're going to move toward the what if we start aligning more to maybe TurboPack's architecture or TurboPack's
Interesting.
APIs in some ways? Maybe we drop one of
Yeah.
our plugin APIs and we pick up one of theirs that is better at certain aspects. Um, but
That
again,
was one
like
piece.
I've
Oh,
I've
I'm
already
sorry.
kind of spoken to the team about like, okay, well, how would we handle deprecation? Because we don't want to thrash the users who might have come from Webpack and really like that format. So it's all about, okay, well, how do we do it very incrementally? And at the same time, we can always just ship 2 sets of bindings. So if you wanted the Webpack style of Rspack, you could say, you could just say, okay, well, maybe we have Rspack core / Webpack, and we just ship the V2 bindings and the Webpack style V1 bindings, which might be slower, but might have the full Webpack API or plugin API. Maybe V2 has a slightly narrower plugin API, but maybe the APIs we provide are faster and are still ample replacements for just how doing a one-to-one a Webpack was not conductive for Rust language. Like,
Right.
it could be quicker if we didn't say, oh, well, this is the JavaScripty Rust version, but if we were to say, okay, well, let's actually harness the power of it and make some adjustments. That might come with a breaking change. But trying to set it up for not just being stuck with whatever Webpack does, but starting with it as a baseline, taking its architecture, and then replacing its APIs as needed in the future, long future. Um, but uh, but retaining the fact that its architecture is the key thing, the fact that it's designed to work well, and that its design passes the tests, and then it's again just about making sure the outputs still match, which they already do. So then we could, you know, reinvent the bundler in the future if we wanted to without sacrificing the existing stability. It would just be, okay, well, what do the users want? Do they want more speed? Do they want us to, are they okay with us dropping this API if it meant we could double the speed again? So it's going to be really dependent on user feedback, um, in terms of like, how do we navigate? Maybe we pull this out and we could make it quicker. Again, like, with Unpack, it's 100 times faster than Rspack because it only has 4 hooks. So,
Right.
but again, this is also the kind of thing that I've always been cautious about. It's the speed versus power equation.
Right.
So, how much am I giving up from a compiler for more speed? And at what point is the yield curve not like, when does the ROI start to flatten out on it? So yes, it could be faster, but I don't uh, I understand the reason we want fast compilations. My take on it is I want a fast enough compilation. And we've done a lot of studies at ByteDance around, like, so when does the yield curve drop off in terms of build speed? Generally, we find, I have a chart somewhere, it's in a keynote, but I don't have to like pull it up. But essentially what we'd found is across every repo that we have, the amount of time CI takes compared to um, how long it takes the PR to go from open status to merge status has a big correlation. So we find that regardless of the size of the PR or the size of the code base, if the build is within 5 minutes, the merge time is 20 minutes. If the build time is over 35 minutes, merge time is 16 hours of latency. So that means that, hey, even if it's doing whatever 40-minute build, generally the kind of product velocity latency, you're looking at a minimum of 16 hours turnaround time. So we know we also if the build takes 30 seconds, the latency doesn't change. It still takes about 20 minutes to get it merged in production versus if it took 4.5 minutes. So we know, hey, being the absolute fastest on the market, give it a second.
Yeah, I can still hear you, but you are kind of coming in electric.
Is it any better now?
Yeah, it sounds better now. I think maybe you
All
needed
right.
to give it some time to buffer. I don't know.
Yeah. So basically the whole product, the product velocity didn't change between a 30-second build and a 4.5-minute build. As long as it was under the bottom threshold, there was virtually no curve.
It's
There
going
was
again,
like,
Zach. Sorry. Give it a second. We were getting spoiled by just having too good internet for a while, I think. But
okay, let's
let's
see.
see.
Maybe now it will be. Maybe now it's better.
Yeah, try singing or something so we can tell.
Testing. 1, 2, 3.
Still coming in kind of robotic. Oh, darn. Well, let's see.
Maybe if I turn my camera off, does that improve it at all?
Yeah, we can try that.
So I just turned off my camera to see if that maybe helped it at all.
Yeah, I think it does. Go ahead and try to explain it again. I'll let you know if
Okay.
it comes in
All
weird.
right. So essentially, like, what we was, okay, if it takes 30 seconds to do the build versus if it takes 4 minutes to do the build, there was no real change in how quick we could get the PR open to the PR merged.
I
So we
see.
kind of found that, okay, well, once you're under the kind of 5-minute threshold, the product velocity curve flattened out. So going for absolute speed didn't matter. It was more about it needs to be fast enough. We needed to keep it within reasonable time and we can avoid the 1,000 minutes of latency for merge. The developer forgets and goes off and does something else and blah, blah, blah. Now, assuming your development speed is quick, good HMR, good building, then um, then that absolute speed doesn't matter in terms of the whole pipeline. Keep it within the golden zone
Got it.
with stronger API.
Yeah. So so you were coming in a little bit garbled towards the end of that, but I think we heard most of what you said, which was essentially there is a golden zone, which is like this needs to be fast enough. If it's less, and that's from what I was hearing you say, it's somewhere between like 30 seconds and a minute, somewhere in that range. Any quicker, like if we go quicker than the golden range, it kind of doesn't matter because like yes, it will technically go faster, but there's other things that are running in parallel in our CI pipelines, and they simply can't go faster than that. So beating the golden range doesn't help us. So something
even,
of
even
like
if we were to say like even if we killed off all the other things, what we had found is like it's like if the build took if all of CI only took 30 seconds,
right.
you would still see a throughput of a 20-minute delay on actually moving it to production. Just I think
Okay.
like at the point once you get it under the speed, there's just the process of development and companies that becomes the maximum throughput.
I see.
But if the build, so even if we took off all the end-to-end tests, if we just said CI as a whole takes 35 minutes, you're looking at about 16 hours in merge latency. If CI end-to-end takes 5 minutes, you're looking at 20 minutes of merge latency. So just ensuring that the whole CI or build process stays within that zone means that we're going to get essentially means like, hey, at that point it starts to flatten out. Even if you were to say take it all down, so all it was the build in CI, it didn't change the product velocity once you get under 5 minutes. You were always still going to look at roughly a 20-minute turnaround time to merge it. So we kind of knew that speed versus power, speed needs to be under 5 minutes.
Got it.
Again, and then we're talking about builds that are like 50, 60,000 modules. So some of the largest apps in the world, they needed to stay within 5 minutes. Anything less than that didn't matter.
Gotcha.
So for us, it's always get the right amount of like ROI on the speed, make sure development is as fast as possible, and then harness the power of Rust. So don't go for a race to the bottom for speed. Go for acceptably fast.
Yeah, fast enough, and then developer
take as much power as we can from that. It's
okay,
like
power.
Whenever I think of a compiler, I always view them as like a tractor.
Yeah.
I don't buy a Lamborghini to plow the field.
Right. That's a good point. So maybe like so obviously like the point you're trying to make is like power. I want to unpack that a little bit, but power at some point becomes more important than speed because speed, as long as we're inside the acceptable range, that's good enough. Then we need to focus on power. And is power to you? Is that just is that like what developers want to work with, or is that like
it's a mix
being
of
able
like,
to do
I would
more?
say
Yeah, go ahead.
optimization. It's the compiler is able to do more actual work. So
Okay.
like maybe so in Webpack. So a good example here is even the best code optimization leaves 50% dead code behind in your bundle, and that's like the best in the industry. You will still have about half your bundle is dead code. The main reason is this comes from the JavaScript days when everything was written in JS and it was too computationally complex to actually do module grade optimization and then chunk grade optimization. So we just did chunk grade optimization. So that means that we don't do cross-module analysis, cross-module optimization. We pack everything into chunks and then we tree shake the chunks. We don't shake the module, pack it in, and then relink it and then shake the chunks again because it's too computationally expensive in JS. So we know that, okay, the only reason that builds are large, we could reduce the builds by 50% if we had something that was faster to do it. Now, obviously, going after that is going to add some compute time onto it, but it being in Rust means that it will be still more than acceptable to do. But again, if we just want to make it absolute fastest, then we would say, oh, well, Terser is good enough, and then that's it. So
Right.
again, speed versus. So one of them would be code optimization, things that the bundler can do, link time optimization, profile guided optimization, things like that we could start to explore. But the other aspect is also, well, what's the API we're giving to the business to actually utilize? How many business functions can we power? Can this thing build things for WeChat? Can it build them for native apps? Can it build it for cross-environment systems? Can it build it for packages? Can it build it for web? Can it do a good job at all of that? Is it flexible? Do we have to drastically change business processes because of limits of the tool? And usually the answer is that's not allowed. So, it's
Yeah.
about trying to say, okay, well, what's going to give us the most business value once we've gotten the speed curve under control? And then our
Yeah.
litmus test for it is, well, since we own some of the biggest apps in the world, it just needs to be acceptable for them. And then we know, cool, well, any other app that's using Rspack is most likely going to be, at best, half the size of one of our super apps. Therefore,
Yeah.
we will experience the absolute worst case scenario. And if our
Yeah.
absolute
Yeah.
worst
Yeah.
case scenario is more than acceptable, virtually every other user that's ever going to use Rspack is going to be orders of magnitude faster.
Yeah. 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 That's really cool. Well, it's awesome that y'all have that worst case scenario. Like that is what you're solving for. So that's really cool.
Yeah, like
Um,
I don't know, had exchanges on Twitter about this thing where I always say, oh, well, absolute speed isn't that important. Sure, if you can do both speed and power, go for it. But,
mm,
like, I would prefer power over absolute speed. And I'll get into some
right.
arguments online where, like, oh, or when I say, it just needs to be fast enough. And by fast enough, I would say, I want it to be at least 10 times quicker than Webpack. Ideally, I'd like maybe 30 times faster than a Webpack build. And then I would say that's generally
Interesting.
fast enough for me. Right now, we're at about 15 times faster, but we don't have any, we just are starting, we just had lazy and incremental compilation go into experiment. In December, we're going to have build caching come out, and then sometime in 22.5, we're going to have remote incremental caching, function level caching, basically like what TurboPack's been marketing, where, oh, if
Yeah.
somebody else built this function in the module, the bundler will not reparse and rebuild it. It'll
Yeah.
only build like at the function level which functions changed. So at
Yeah.
that point, we're going to drastically accelerate speed, but one that also came from the fact that we had enough API and power to build something like that. This is a similar reason why TurboPack is the way it is. It's massive, it's complicated, it took forever to build, but it's architected around there's many other ways that you could speed it up that don't just eat into power.
Right. Interesting. That's really neat. I was going to ask specifically about TurboPack just because to me it represented something that was like a little bit different in terms of how it was approaching things, which was just as my understanding. I mean, you can help me out with this because I'm sure it's like limited, but my understanding is they were going to take things down, like essentially take things down to the AST level, so the abstract abstract syntax tree, and they're going to actually start caching pieces of that tree so that with every change that you make, they're going to like only identify the pieces of like the AST for your entire app. They're only going to like rebuild the pieces that changed and were affected by like your last save. Is that fundamentally different than everything else right now?
Yeah, they're the only, well, maybe, okay, so maybe the nearest thing would be Parcel. So Parcel is super underappreciated and always forgotten about, but Parcel had, like, the only reason Rspack doesn't use Parcel's API is we just knew Webpack better. But Parcel is, like, immaculately well designed. And Parcel actually has the ability to reuse its AST in between the transforms. Pretty much every
Really?
other tool, like if you use Rollup or ESBuild or even Webpack, whenever you're like Webpack provides the AST, but it provides it in a different format. So nobody ever reuses Webpack's internal parser's AST. Parcel, on the other hand, it can recycle its AST. So when you pass it to a loader or to a transform, it can take the AST from that and say if it does string, like AST to string or string to AST or AST to AST, it actually can recycle that process. Everybody else basically just puts it back into string, parses it again, converts it back to AST, transforms it, puts it back into a string, and passes it along. So you reparse several
That's
times in a lot of
interesting.
them. Parcel
So
is
it's
the only
almost
one that
like
has really good recycling and reuse of that AST. And I
gotcha.
imagine Turbo probably is going to try to be a bit of a mix of that, but their whole idea is caching it at the AST level. And
Mhm.
this is something that is pretty much going to be how Rspack ends up doing it in the future when we roll out the function level caching. For now, we're
Gotcha.
going for incremental portable cache, so that'll be like a remote cache that you can share, and then we're going to upgrade it to basically have it the exact same uh, cache system as TurboPack will have.
Right. That's really interesting. I actually want to latch on to one more thing, and then we should probably wrap this up because we've been going a while. But one of the interesting things I heard you say was a lot of these other tools, it's like they are AST aware, but between each hook or between each step, they're taking the AST, but then they're putting it to a string. So like the string, the text is offering as the source of truth, and we derive an AST from that.
Yeah.
So was parcel doing the opposite? Was the AST the source of truth? Because to me,
Yeah,
that
I
seems like
believe
the way to
so.
go, honestly. But I don't know the world like nearly as well as you or nearly as well as anyone working on this. But it seems like that would be the way you'd want to go, is like use the AST as the source of truth, operate on things from there, like be able to pipe on operations from there. And then at the very end, like at the very end
Convert
of
it to a
all of
string.
it, yeah, output the string. So like if we're going back to the function, um, like if as we're unpacking this black box, if each one of these is like, well, actually, it's not this straight line through. It's actually like here's one step, and that's going to do as AST and then a string. But then we go like it's this is weird back and forth. If there's weird like AST to string, AST to string, AST to string all the way through, I don't know that it doesn't seem right, I guess. And it also just like the different things you'd have to do along the way. Like you have to support the string. You always have to be working with the string as opposed to just let's focus on the AST. Let's focus on the abstract piece of it instead of always having that. Is having the AST as the source of truth, even though it has nothing to do with your input, has nothing to do with your output. If that becomes like your source of truth all the way through until maybe like the last step when you output the string, I would think that would be better, but I don't know. That's
So there's a few challenges. So the main reason that a lot of these tools end up just saying, okay, well, yeah, they can provide their AST, we just don't use it. Like whenever you write a loader in Webpack, like if you write a Babel loader, you're gonna Babel parse it again. In theory, though, the loader also provides the AST, so you could skip the parse and just say, okay, transform the AST and pass the object along. The challenge
see.
we've found is that there's so many different parsers and different AST definitions that it becomes a little bit more difficult to actually always do that, because like Webpack uses ESTree, parcels
Okay.
might use Acorn, some might use SWC, so you kind of get to this place where, okay, yeah, you can, but how often do you have a case where all the tools you use all are using the same AST to actually reuse it?
Right.
So
Okay.
sometimes just in terms of, okay, easy to manage, easy to utilize, it's just easier to say put it back in a string, and then the bundler can pull it back into their AST that they walk and crawl separately from maybe what Babel's doing or whatever. But
Gotcha.
ideally, like how Parcel has done it, the idea is to utilize and recycle the already parsed AST, and to not do parse and then transform again, but just transform and you already have the syntax tree coming back to you that you can reuse, and you can skip parsing steps along the way. Now,
Yeah.
in an early version of Rspack, we actually did that, and we used Parcel's AST recycler. It worked, but the issue is it was mostly like an architectural challenge, because a lot of Webpack's linker and tree shaker and all of that is designed for like a string-oriented or string-replace style approach. So it just became like edge cases started to appear. So we found, okay, it's actually just more stable to use this current format and speed it up, and it's also it can be utilized a little further out. Now, I would say
Yeah.
probably in the future, now that all the test cases are in place, and now once we go into the like Rspack v2 era, maybe we start looking at, okay, how do we change that, especially as SWC is kind of becoming the standard in a lot of places. It might become a lot easier to make this the case. But again, if we do that, the challenge we're getting back into is design. So now we're back to why we even started with Webpack in the first place, was how much edge case are you producing by trying to build something that's never been built before. But the nice thing is TurboPack has essentially got a very similar architecture to Webpack. There's some changes in like how the module graph works and how HMR works, but in large, if you look at like its output, it looks like a Webpack runtime. except they don't use the prototype chain. They just pass an object, and all the prototype methods that were on the Webpack runtime is now an object with all the methods as the first argument.
Right.
But again, the nice thing about this is TurboPack is effectively absorbing the hardest part, which is bundler design. So with design absorbed by the guy that built Webpack, that also means that it's a lot easier for us to go, okay, well, the design works. We can simply look at what they did and do it again and just do it within the Rspack ecosystem. So creating a bundler is quite easy to do. Designing a good one is a lot harder. So if the design costs are absorbed, at least for us, we're very fast. So it doesn't take us long to take something from one language into another or to do anything like that. But the risk is around the design phase. So when function level caching comes out there, that's part of where we're probably going to draw on it is we already know this architecture very well. It's a very similar architecture to kind of how Webpack has been done, and all we have to do is port it, and porting it is very, very fast. As you saw with making Rspack in the first place, it took us a few months to get it production ready. And a lot of that is because we got to skip the design phase for the most part, and that's really where you get caught.
Well, your whole spec was there. Your whole test suite was already there. So you just were making things pass, which when you can finally get to that, where you have like a spec from, however many years of people using it, that I imagine that makes development really straightforward, at least not to say easy, but straightforward in the sense that let's get all these things to pass. Then we're ready. Like we know we're production ready. So that's really cool. All right, Zach, this has been awesome. We've had 2 hours now. We've had some technical difficulties. We've been all through a lot of this stuff. We answered 2 of my questions, I think, and I had a button. So I'll talk to you after the stream just about maybe we can get something scheduled to go more into stuff. But this has been super helpful for me just to understand more what's going on with bundlers. Hopefully it's been helpful for a lot of people out there. I see a lot of stuff in the chat about like Angular and Rspack. Gulp's been working on that stuff. So making like an easy migration for like the standard Angular stuff, just to use Rspack. I think we actually did our last live stream on that. So be sure to check that out, and be sure to check out Gulp's package if that's what you all are interested in. And we really appreciate you all coming by. Yeah, go ahead.
One point before, just because you brought up Angular, I think this is also a really interesting case of just like the challenges that are around like what I just call like a weaker build API. So I think Google spent like over a year trying to shoehorn ESBuild and like working heavily on ESBuild to get it to build an Angular output. And that does just show the challenges when you're saying, oh, okay, well, yeah, it's so quick and it's so simple. Yeah, it's simple for you, but then when you need to like do something like, use it for a framework or something like that, for Google to take an entire year to get ESBuild to a point where it could build Angular just shows this constraints that you can have if you don't have the right APIs to actually do it. A company as large as Google spent a huge amount of time to get the Angular build to work there, which, probably it didn't take that long to write the Webpack plugin for it. But at the time, it was a speed issue. Rspack didn't exist at that, or it was brand new, and they were already like 6 months into trying to get this to work. So, it was like a timing issue, but you can still definitely see that constraint of simplicity or, simple plugin, or simple API is easier to adopt, but maybe difficult to scale. And, it's all about that balance of power and speed.
Yeah.
It's a good one.
It goes to that equation you're talking about. I think that's super true. It's just like, yes, we can make things a lot faster, but it comes at the trade-off of most of the power is gone. So we want to make sure that power is accommodated for too. So it's really cool just to hear all of these things in your mind as you're working on this stuff and like where your priorities lie for a lot of this. So that's super interesting. Hopefully, if we can do another one, I'd love to get into the weeds, like have you show your code and all that kind of stuff. So that would be real cool. But we'll wrap it up here.
Part two.
Yeah, sounds great. But thanks everyone for joining. We'll wrap it up here. Bye.
Bye.